You know what is cuvette?
No.
Cuvette is like a cylinder, not cylinder, but in a long shape, in a square like this. Okay, that is we call cuvette. So that cuvette is contain a solution to measure the solution sample. Okay, and we are having also this is a solid sample. Okay, so we are later on we'll be using this because we are having a thin film sample. So you just bring up here, okay, open up, and then slit in your sample to make it close, cover all the holes here. Okay, so the light will be passed through in this way. That's why your films will be facing in this way. Okay, so this is the light source passing through here, and then detected in here. Alright. So this is the detector. So when you close it, don't bang it. Just slowly close it. Okay, I'm gonna let you come over. Okay, this is the software itself for the interface. We are using a UV Win Lab which comes with the machine itself. Okay, so in here, this is the UV Win Lab Explorer provided by the machine. Alright, so we need to create a new method. The method here means the new recipe for your own sample. Alright, so we go to new method and then choosing the high performance because this is 950.
950.
So high performance is lambda 950. Alright, so next, and then create your own name label. Okay, your group is S3, right? So bring CD or not?
Yes.
Yes, sir? Okay, later on use.
Pun 7 GB buat dia. Okay, ini klinik kan? Ini klinik. Bawa pada hospital swasta. Hospital kerajaan dia panggil ambulan, dia ambil kisah sangkal. Kalau hospital swasta tak, hospital kerajaan dia panggil ambulan, dia kisah sangkal. Kalau tak panggil ambulan, dia assume komunitas biasa je. Tak. Kalau yang naik ambulan tu memang teruk. Even kau biasa.
Alright, starting we are going to measure the transmittance of the sample. Okay, normally we are going to set, okay, listen carefully, later I will ask you to do this. Okay, so we are in the data collections, we are going to set only this metal setting 800 up to 200. Dia balik sini, okay, from 800 to 200, and then we go for transmittance. Okay, in here we have absorptions, transmittance, dielectric constant, optical dielectric, and reflections. Okay, so the main three components that we're going to measure is actually absorption, transmittance, and reflectance only. But in today the lab we're going to measure the absorption and transmittance. Okay. So transmittance, and then we go to corrections. We take this block-in baseline. Okay, this is to activate the internal attenuator that to cut down the unwanted wavelength. Alright, so we go to sample info. Okay, if you have multiple sample, then you click on 6 example, then you come to 6, then you put the label. But if you only have one, so just one, so you sample To label it, just click as 3. Okay?
Okay.
Okay. So later on you will going to save this result. So after this, then you click on start. Make sure before you start, you will pop up a message to ask you to remove all the samples, all the remaining that you have scanned last time, to make sure empty, so that it will start to initializing the machine itself. Okay? Okay. So now the machine is starting to initialize. Okay, remove sample and press OK to perform 100% auto zero. So just press OK. At this moment, make sure don't bang or knock or just don't go and make noise, disturb
The machine.
because any disturbance, it will affect your result.
Or even though it's in the machine.
Yes. Because inside is using a mirror.
Okay.
The mirror is like rotating. Okay, just slightly only. But within the knock of the bang, it could create the vibration that vibrates the mirror itself. Okay. So now just leave it to initialize. Okay. Right. My questions. Okay. What is wavelength?
What is
Wavelength. Don't write on there.
What is wavelength? The measurement.
What is light?
A bundle of photon.
Huh?
Like a bundle of photon.
Okay.
So that is the measurement of the light. Wavelength, I mean measurement of the light.
Okay.
The
Measurement of light. Okay. Okay. Light is consists in coherent spectrum or incoherent beam, or we call it incoherent ray. Okay. So, in scientific way, we call it photon. Okay. Photon consists of internal energy. Right. So how to calculate the photon energy? There's the equations, right? And then the interrelation between the photon energy and the wavelength is
speed of light.
yes, h nu.
H.
E
E
equals
equals to
to
H nu over lambda. H nu saja, kita ada.
Okay, so we can calculate based on each single wavelength, and this wavelength is actually within the light. Okay, so this is the light source fixed. Okay, the halogen and deuterium light source, it consists of multiple wavelengths. Right. So we are actually measuring from 200 to 800. So this is the range of wavelength. Okay, so inside it will start to split or shine or how to say provide the wavelength according to what we need. Okay, using the grating mirror, using the beam splitter, using the attenuator, okay, using the chopper. Internally, there's many mechanisms inside. Okay, so in here we are actually measuring the transmittance and absorbance. But why we need to measure this? Why? Why we need to measure emissions, transmittance? Why?
No idea.
No idea. You remember?
Dia letak tempat sama kan.